Alright, so this time we're going to talk about some exponents and radicals. So basically I put up the list of the laws, whether that we write the radical laws. So first of all, let me start here. Radicals are, so if you're taking the nth root, this is what we're going to call a radical expression. In particular the square root. When n is 2, we don't really write it in there, and you just have the square root, and then that'll be a 1/2. So if you have the square root of a, that's 1/2. In general, we say the nth root, or the number which multiplied by itself n times would give you exactly a. The nth root of a is going to be a fractional exponent. So what that means is now you have an exponent, but now that's number. So essentially you can use all of these laws for radicals will happen because radical is an exponent, and then we have exponent laws. So these are the laws you want to memorize essentially. Anytime you're confused or you have a radical, especially if you're going to take calculus eventually as well, if you're just learning exponent laws, then that's fine. But calculus, eventually we're going to take derivatives of these kind of functions and stuff like that. You definitely want to see that the nth root function, or the nth root, is a fractional exponent, 1 over n. So these are the rules that we have regardless of what kind of problem or what they make it look like. If I'm using exponent laws on something, trigonometric functions or regular functions or numbers or a's and b's and c's and d's or x's and y's and z's, it doesn't matter what I'm calling them. What's important is the fact that I use these same laws systematically. So let's do the first one. So what we have now is the dreaded evaluate the expression, and you don't know what that means or how to start essentially. I also should have wrote it, but what I'm going to do is the question may say leave it with no negative exponents, leave your final answer. So basically what I'm going to do is compute, because when I have numbers they mean just evaluate and compute what this is and simplify it into lowest terms and then tell me what it is. This one we're going to simplify and use a bunch of the laws to combine the powers of 2 and tell us what it is, and this one will simplify to give a number, and in each one we'll leave no negative exponents. So the first one, I have 2 over 3 to the negative 3. So I'm going to use this law right here. Essentially what that says is I have 2 over 3 to the negative 3. So what that says is first I'm going to flip them, and then the exponent will become positive, and I'm going to distribute onto both. So using the rule, that says that this will be 3 to the 3 over 2 to the 3. That's what the rule is saying. You flip it and invert. We can also do it like this if you don't want to memorize the rule. First I'm going to use the distribution rule. First, even though I have a fraction, I can write that as 2 times 1/3, and I can write it as distribution onto both. Or we could write the other law. If you have a over b to the n, that is a to the n over b to the n. So I'll do that instead. The negative 3 exponent goes to 2 to the negative 3 over 3 to the negative 3. And then now to move the exponent to become positive, I move it across the division sign. So that will equal 3 to the 3 over 2 to the 3. 3 to the 3 is 3 times 3 times 3, which is 27, over 2 to the 3, which is 4 times 2, which is 8. That's the first one. The second one, I is 2 to the negative 9 over 4 to the negative 4. So first of all, what I can do is to make these exponents positive, I can write this as 4 to the 4 over 2 to the 9. Then what I'm going to do is notice that I'm going to be clever and notice that 4 is 2 squared to the 4. So I turn the 4 into 2 to the power 2. So that, how do I know I might want to make that move? I want to use these laws, and they all say if you have the same base you can combine everything. So I see a 2 and a 4 is 2 squared, so it's a power of 2, and now I have the same base. Here I'm now going to write that as I'm going to use this law right here, where I have 2 to the 2 to the 4. I'm going to write it as 2 to the 2 times 4. So this is 2 to the 2 times 4 over 2 to the 9, which is 2 to the 8 over 2 to the 9. And now in reverse, if I have this, I can write this as, well, I'm going to use this law, but in general I want to bring it, I didn't want to leave any negative exponents, so I'm going to bring this down. This will be 1 over 2 to the 9 times 2 to the negative 8, technically. And then I have that I can write this as 1 over 2 to the 9 minus a, which is 2 to the 1, so the answer is 1/2. For the third one, we now are going to simplify in a slightly different manner, but we're going to use radicals. Remember what this says is, so I, or in part 3, is the third root of 8 over 27. Basically what we want to do with that is, now nth roots are an exponent, so the thing I like to do actually is this. It's 8 over 27 to the 1/3. I like to use the definition. What I've done is, my first move I like to do is I've turned the radical into an exponent. So I've gone from radical land into exponent land again, and then I can see its exponent laws. Now that I've made that move as my first move, now I can apply these exponent laws to this 1/3 exponent. This is now going to be 8 to the 1/3 over 27 to the 1/3, because we can distribute it onto both the top and the bottom. Now this is 2 to the 3 to the 1/3. If it's going to cancel, and I have a denominator, I want a numerator which is also a 3, over 27 is 3 to the 3 to the 1/3. And now I use this law again twice. I combine, if I have it like this, which I do, I can turn it into multiplication, which is 2 to the 3 over 3 over 3 to the 3 over 3. There's 3's everywhere, but that's a 1 basically. Those are going to cancel. So what I see now is, using that law, is I get 2 to the 3 times 1/3 over 3 to the 3 times 1/3, which is equal to 2 to the 1 over 3 to the 1, or 2/3. Two names. Okay, so this is Jasper. She wants to know what's going on. She's... Oh, who is it? I know, she sees 2 other cats that are now looking at her, and now she wants out to go play. Now they're all going to show up. So, we're going to do exponents of radicals again. Basically what we want is, this time I've still got the rules written down. They never change, so eventually I may not put them in the videos, but they're always the same. Take a picture of it now. This is roughly what you need, or the most condensed versions of the more important exponent laws that you're going to need. In particular, nth roots are 1 over n exponents, so then you can just use exponent laws. This one, they want us to simplify the expression. Now, instead of having numbers, we've got x's and y's and z's and some numbers in there, but we use the same laws every time regardless of what they give us. We use these laws to simplify these expressions, and they want no negative exponents this time. So here we go. 1. What they want is, first of all, I have an exponent on this and an exponent on this, and then we're going to multiply. But this is a negative exponent, so first I can write it as 2x squared y cubed to the 2. I didn't do anything to this yet. What I'm going to do is something to this with the negative exponent. To bring it to a positive exponent, I have to write it as 5x to the 4y. Now that I've dealt with the negative exponent, I've already eliminated them, but I can start using the rules, and then as I use them, I bring the smaller exponents across the division sign to the larger exponents every time, so that I keep the exponents are positive instead of negative. So my next move is, I do have a power, and my rule is right here. If I have a power to a product of any number of things, then I can distribute that into everything. So this is equal to 2 to the 2, x squared to the 2, y cubed to the 2, over 5x 4y. I got a little bit tight in there, but now I can use the laws. Again, I'm going to use this law to combine. 2 times 2 is 4, and 2 times 3 is 6. So whenever we have the brackets like that, you can know that it's multiplication in the exponent, and this is 4. So this equals 4 over 5, x to the 4, y to the 6, x to the 4, y. These x's cancel. As soon as you have something over something, you can cancel it in the expression. This is technically, we're bringing this exponent up, and it's 4 minus 4, which is 0. X to the 0 is 1. So this has gone away, and then again what I see in the last one is that I have a y to the 1 and y to the 6, so I want to keep it a positive exponent, so I'm going to bring this to the top. So this is 4 over 5 y to the 5, and that's the simplified expression for number 1. To simplify this, first I'm going to deal with the negative exponent, so I can flip these. Essentially I'm doing this again, this rule 5, so I can write that as x to the 4 y z to the 7 squared over x squared y cubed z squared to the 2 as well. So basically I've inverted it and then made the exponent positive. Now what I do is distribute that twice using this rule. I can put it onto as many ones as I want, but it distributes on there onto the top and the bottom. So that becomes now equals x to the 4 squared y squared z to the 7 squared over, that 7 didn't work, over x squared squared y cubed squared and z squared squared. Again, if you see what's happening, you can skip that step and write that as x to the 8, but now I'm using this rule, and x to the 4 to the 2 is x to the 4 times 2, which is x to the 8, and so on. So then I have x to the 8 y squared z to the 14 over x to the 4 y to the 6 z to the 4. And then coincidentally the x's are smaller on the bottom of the exponent, so I'm going to move it to the top, and 8 minus 4, and same with the z's, the 4 is smaller, so I'm going to bring it and it'll be 14 minus 4 is 10, but here the y's, the exponent on the top is smaller, so I'm going to bring the 2 to the 6, and 6 minus 4 is 2. So our final answer is x to the 8 y to the 2 z to the 14 over x to the 4 y to the 6 z to the 4 is technically, now what I'm doing is x to the 8 minus 4 z to the 14 minus 4 over y to the 6 minus 2, which is x to the 4, sorry, z, x to the 4, twice, my brain really wants y to be on the top. Bottom, you're on the bottom, z to the 10 over y to the 4. Exponents and radicals.